Assalamu alaikum. Hope you are doing fine. We know dimension of a physical quantity is the power to which fundamental quantity must be raised. And we have learned about the dimensional analysis as well. In this video, we are going to discuss the application and limitations of the method of dimensional analysis. When we talk about the application, dimensional analysis have got three applications. One is it can be used to convert a physical quantity from one system of unit into the another system of a unit. Second, it is used to check whether a given equation is dimensionally correct or not. Third application of the method of dimensional analysis is it is used to find the relationship among different physical quantities. Let's discuss these things one by one with the help of a few examples. Now take one problem 1.12 in which pressure regards P1 is given whose value is 76 centimeter of mercury. First, I convert this value in CGS system. We know pressure of a liquid is mentioned as H rho G. Here H is the height of the mercury column, and rho is the density, and G is the acceleration due to gravity. So first, I will convert this pressure. I take it as P, then I write this in CGS system. In CGS system, the value is taken as P1, which is nothing but the height is 76 centimeter, then density is 13.6, then G value is 980. This acceleration due to gravity, and the unit in a CG system is dyne centimeter per centimeter square. Now, this is the value of pressure in CG system. Then what will be the value of pressure in a SA system? That is as P2 that I am going to find out. In AC system, the unit of pressure is Newton per meter square. And what is pressure? Pressure is force per unit area. And force is something but mass into acceleration, and area is length into breadth. Okay, this is the expression that represents a pressure. It is so, the dimension of pressure can be obtained by substituting their value. For mass, we have m power 1, acceleration L, t power minus 2, L power 1. Here, for length, dimension is L, for breadth also the dimension is 1. So, L is square. Now, this can be easily obtained from the table given in the book. When I take L square to numerator, the value obtained is something like this. M power 1, L power 1 into L power minus 2. So, what do we get? L power minus 1, then T power minus 2 as such. So, the dimension of pressure is M power 1, L power minus 1, T power minus 2. Or pressure have dimension of 1 in mass, minus 1 in length, and minus 2 in time. This is what it says. So let's get into the method. Now, this method is based on the fact that the product of numerical value n with the unit u is a constant. It means if I have a numerical value in one system of unit u1, when you multiply these two, then it will remain similar to the numerical value n2 multiplied with the another system of unit. This is what it means. So I'll go ahead. Now I'll apply this method to get the value of pressure in SI system. So here P1 is the pressure in one system of unit. It is multiplied with the it's a unit. What is that? M1 L1 T1. Now I take a dimension as A, dimension of L1 is B and dimension of T1 is C. Then it will be equal to P2 multiplied with M2 power A, L2 power B and T2 power C. Now my aim is to get the value of P2. So I keep P2 one side and remaining terms are taken to the other side. So what I get if I do so, I get this. M power A, L power B, T1 power C divided by M power 2, M2 power A, L2 power B and T2 power C. This is what I get. Then if you want, you can also rearrange it. You can take it to the left hand side and this term can be written in the right hand side for the convenience. I write it like this. P2 is written this way. Is equal to P1 into, see what changes I am going to make now. If you look at this side of the equation, we find there are terms which have got the same power. Now these two terms have the power A, these terms have got power B and these two terms have got power C. So in a common, it can be written as M1 divided by M2 power A. Then multiplied with L1 divided by L2 power is B. In this case T1 divided by T2 power is C. This is what we obtain. Now whatever things you find here, M1, M2, L1, L2, T1, T2, all of them have got two values. Here M1 the mass in a CJ system. This stands for 1 gram. And L1 is the length in CJ system. This system length is weighed in centimeter. So L1 is 1 centimeter. And time is 1 second. This is the unit of time in the CJ system. Then the unit of mass, length and time in a SI system is taken as this. M2 1 kilogram. Then L2 is taken as 1 meter is the unit of length and time is weighed in second in both the cases. Now I am going to substitute these values in the above equation. So what I'll get? I'll get this. P2 equals to P1. We know the value of P1, which is nothing but this. Now M1 is 1 gram divided by 1 kg. 1 kg is the value of M2. Then I write the corresponding values in the respective place. For L1, you have 1 centimeter. For L2, 1 meter. Then even 1 second, divided by 1 second. Then the power is A, B and C. Now I make certain changes to this part of the equation. See what I do? I am going to write this something like this. P2 is equal to P1 into, see, 1 gram is kept as such, and down we know there are 1000 grams in 1 kg. So 1000 gram. Then here 1 centimeter divided by, there are 100 centimeters in 1 meter. 100 centimeter. Whereas here there is no change. 1 second divided by 1 second is 1. So if you divide this two, what do you get? You get 1 now. Oh, get 1. That I mentioned here, 1. Power is C. Here the power is B. And here the power is A. Clear? Now, the next step, we know 1 divided by 1000 is written as 10 power minus 3. How we can write that? So P2 is equal to P1 into, here it is written as 1 by 1000 is written as 10 power minus 3. Power A multiplied with 1 by 100 is 10 power minus 2 power B. Then the remaining term is written as this. Now you may wonder where this gram centimeter has gone. Here if you divide it gets cancelled. So only we have mentioned the value. So unit is not mentioned here. I think you understood. G by G becomes 1. So centimeter divided by centimeter becomes 1. Like that you can take it. Now what is the value of A, B and C? Let's find out. For that what I do, I am going to compare A, B and C present in this part of the equation with the dimension of pressure. Now, the power of M here is A, whereas the power of M here is 1. So, what do we get? Comparing the power. We get comparing the power with the comparing the power with the dimension, with that of dimensions is nothing but in the place of A we have 1. In the place of B we have a minus 1. In the place of C you have a minus 2. Now if you find it difficult to get the value of A, B, C with the help of this expression, means you can compare the dimension of the power of this dimension with that of this part. So in the place of A we have 1, in the place of B we have minus 1, in the place of C we have minus 2. This is what we have mentioned here. So I am going to substitute these things here. What I will get? P2 will become equal to, now what is the value of P1 that I am going to mention? 76 into 13.6 into 980 multiplied with this three things. 10 power minus 3 power 1. the place of A. They are multiplied with the 10 power minus 2. The power is minus 1 here. Then into 1 whose power is minus 2. Okay. Here we know if we square 1, the value obtained is 1. Now, even if you take 1 power minus 2, the value obtained is equal to 1. There is no change in it. Now, I go ahead. Now, P2 value. Now, we return as 76 into 13.6. Okay. I'll do one thing. I multiply these 3 parts. Then what do I get is this 1.01 into 10 power 6. It is multiplied with this part. 10 power minus 3 multiplied with power 1 is 10 power minus 3. Then 10 power minus 2 with the power minus 1 is nothing but minus 2 into minus 1 becomes plus 2. So 10 power 2. Then this part is 1. So what value do we get here? See, look at this part carefully. But this is step. You see how I'm going to multiply tens with some power. 10 power, right? 6. When we multiply two values which has got power, in such case, the base is kept as such. If the base is similar, it is kept as such, whereas the power gets added up. So 6 is added with the powers minus 3 and plus 2 is what I do. Then what I'll get? I get this 1.01 into 10 power 6 plus 2 is 8. 8 minus 3 is 5. 10 power 5. And the unit of pressure in SI system is Newton per meter square. So the final expression, the final value of pressure in SI system is 1.01 into 10 power 5 Newton per meter square. So here I box this. This is the final expression which gives us the value of pressure in the SI system of unit. Okay, so we have converted this value which is given in CBSE system into this value in the SI system. I hope I have understood. Now I will solve one more problem to explain this concept of converting a physical quantity from one system of unit to another system of unit. Now I will convert the value of G. G stands for universal gravitational constant. If its value is given in SI system, then what will be the value of G in CBSE system? That I am going to find out. Here, gravitational constant G in the SI system have find its value equal to 6.6 into 10 power minus 11 Newton meter square per kilogram square. This is the value of G in the SI system. I am going to find out the G value in a CGS system. Let's do that. Now, before going ahead, let's find out the dimension of G. How to get that? We have learned in the Newton's universal law of gravitation that force of attraction is directly proportional to product of masses and inversely proportional to square of distance. So this can be written as F is equal to G into M1 M2 upon R square. Now from this, G value is equal to F R square upon M1 into M2. By cross multiplication, we get the value of G. So the dimension of G can be written as dimension of G is obtained by substituting the dimension of each term in this equation. For force, write this as F R square upon M1 into M2. Then force is mass into acceleration. Mass into acceleration is force. Then it's taken as such M1, M2. Now I am going to substitute the dimension of each term. Mass dimension is M. For acceleration dimension is L T power minus 2. For this distance, dimension is L power 2. Here I told you earlier, when there is no power, it means if you find equality with no power, means the power is 1. So L power M power 1, L power 1. That way, here we have mass twice. So the dimension of M1 is M and the dimension of M2 is also M. So we write M twice. M into M is M square. Here L1, L power 1 into L power 2 is L power 3. Now the dimension of G. Dimension of G is obtained if I take this term to numerator. When I do so, what happened? L power 1, L power 1 is multiplied with L power 2, which is present here. Beside this, I have rearranged it. Then T power minus 2. Now I take M power 2 to the numerator. So what will happen? 2 will become minus 2. So on simplification, it becomes something like this. M power 1 into M power minus 2 is M power minus 1. Then this 2 becomes L power 3 and here this becomes T power minus 2. This is the dimension of G. Now how do we get the M power minus 1? I told you earlier, when we multiply two terms of the same type having different powers, in such case we add the power. So 1 is added with the minus 2. What do you get? Minus 1. And here this 2 when we multiply, we add the power. L power 1 plus 2. So 3. The same method is followed here. What I have shown you in the previous problem. Now let's go ahead. I am going to apply method of dimensional analysis to get the G value in CGS system. So I will do like this. G in CGS system multiplied with M1, L1, T1. Here the dimension is taken as A, B and C. And this side G in the SA system is multiplied with the inside unit. M2 power A, L2 power B, and T2 power C. It's done. Then afterward, our aim is to find the value of this. Now I'm going to find out its value. So this alone kept on the left hand side, and the remaining terms are taken to another side. So what do I get? Get this. IGCSE system. Then M1 is taken to that side. M2 power A divided by M1 power A. Then L2 power B divided by L1 power B. A. Then this side T2 power C divided by T1 power C. Now this can be written as this as such. Now I simplify this. See, the terms have got same power. So it was M2 divided by M1 power A. Here L2 divided by L1 power common power B. This side T2 divided by T1 common power C. Now we know the value of G in SI system. Nothing but this. Yeah, that I am going to mention later here. G in CG system is equal to G in the SI system. Now here, okay, for going to the next step, let me mention the value of M1. M1 here is equal to this mass in a CG system. In a CG system, mass is measured in a gram. L1 is length in CG system. Length is measured in CG system in centimeter. Then time is measured in second. Whereas M2, mass in the AC system. In mass, the unit of mass in AC system is 1 kilogram. The unit of length is meter, and the unit of time is same, 1 second. Now I'm going to substitute this value here in this equation. These things in the above equation. So what I get this. CCGS equals to G in SI system. In the place of M2, write 1 kilogram. Then the place of M1, write 1 gram, and follow the same method, the power A. For L2, we have 1 meter. L1, we have 1 centimeter. Power B. Then T2, there is T2 is 1 second. T1 is also 1 second. It is raised to power C. Got it? Now, I do certain changes to this. Let's see what is that. Now, here, 1 kilogram have got 1,000 grams in it. Kilo means 1,000. You remember that. 1,000 gram. Here we have 1 gram. Power A. Then there are 100 centimeters in 1 meter. 100 centimeter divided by 1 centimeter. Power B. Then 1 second. Divided by 1 second is 1. So 1 power C. Yeah. Okay. Now, what is the value of A, B and C? This can be obtained by comparing this part with the dimension of a G. Now, if you compare these two, you will get the value of A equals to, in the place of here the power of M is A, here the power of M is 1. So in the place of A, we have minus 1. In the place of B, we have 3. And in the place of C, we have what? Minus 2. That I am going to mention here. Let's see what do I get if I do so. And now before going ahead, let's see, I write this part. 1000 divided by 1 is 1000. 1000 can be written as 1000. See how to write this in terms of power of 10. Write 10, then count how many zeros are there in 1000. 1, 2, 3. Then raise 10 to the power 3. Then how to write 100 in terms of the power of 10. Say, write 10. Then count how many zeros are there in 100. 100 we have 2 zeros. So raise 10 to the power 2. So 100 is written as 10 power 2 and 1000 is written as 10 power 3. Got it? So here G and G get cancelled. We get 10 power 3 power A, and here 100 is written as, see, anything divided by 1 remains same. So it's taken this way. So 100 is written as 10 power 2. Centimeter get cancelled here. Power B, and here 1 power C. Now I will mention the value of A, B and C here. What I get this. Yes, I is equal to 10 power 3. And the value of A is minus 1. The power minus 1. Then it's multiplied with 10 power 2. And the value of B is 3. Raised to power 3. Then here 1. In the place of C, we have minus 2. 1 power minus 2. This we have. We know when 1 is multiplied, when 1 is raised to any power, the value is going to be 1 only. So 1 power minus 2 is 1 here. Anyhow, now I substitute the value of G in ICSE system. That's nothing but 6.6 into 10 power minus 11. This is the value of G in SI system. It's multiplied with what? 10 power 3 power minus 1. So what do you get? Here 3 is multiplied with minus 1. We get minus 3, 10 power minus 3 into 2 is multiplied with 3, 10 power 6 and 1. There is 1 as such. I told you earlier. Now, see the most important thing that I do here. Look at this carefully. How do I multiply these 3 tens with different power? Here I write a 6.6 as such. Then I multiply this with 10. Then I raise a 10 to this power. See, when we multiply, the power gets added up. I told you earlier. Minus 11, minus 3, then plus 6. Here 11, 3 minus 14 plus 6 is 9. So the value obtained is, this system, we have the value 6.6 to 10 power 14 minus 14 plus 6 is 8. Minus 8. This is the value. And the unit is this. Dyne in the place of Newton and centimeter in the place of meter, centimeter square. Then in the place of kilogram we have gram in a CBSE system. per gram square. This is the final value that gives us the value of G in a CGS system. This is how one can use a dimensional analysis method to convert the value of a given quantity from one system of unit to another system of unit. Now we'll go to the another application of this method. Now we'll discuss the second application of the method of dimensional analysis. Let's do that. For that, I will take the first equation of motion. What is first equation of motion? First equation of motion is V equals to U plus AT. Now I'll check whether this equation is dimensionally correct or not using dimensional analysis method. Now before getting into that, we must know the dimension of the terms used here. Here V stands for final velocity, U stands for initial velocity, A stands for acceleration and T stands for time. No? The dimension of V. V is nothing but displacement divided by time. The dimension of a displacement is L. The dimension of time is T. So, the dimension of V is LT power minus 1. Then, the same thing holds good for U as well, because both of them stands for velocity. Then dimension of, I can write V and U. The dimension of A. A stands for acceleration. Now we know acceleration is the velocity divided by time. The dimension of velocity is LT power minus 1 and the dimension of time is T. So when T is taken to the numerator, we get, it becomes T power minus 1. So T power minus 1, already we have T power minus 1, then this T power minus 2. LT power minus 2 is the dimension of acceleration and the dimension of time is a T. The dimension of T is nothing but this. This is the dimension of time. I told you earlier, when there is no power, then that means the power is 1. So I write it this way. Now I am going to apply this method, this equation. V is equal to U plus AT. I am going to substitute the dimension of V, but LT power minus 1. And the dimension of U is LT power minus 1. Then yes, the dimension of A is LT power minus 2. So then the dimension of T is capital T. When these two are multiplied, T power minus 2 into T, we get, we obtain, see, T power minus 2 multiplied by T. You get this, T power minus 2 plus 1. That is nothing but T power minus 1. The next step appears something like this: LT power minus 1 equals to LT power minus 1, and even here we have the same LT power minus 1. You can see this equation has got three parts. And all the parts of this equation have got the same dimension. So this implies that when different parts of an equation have got same dimension, only then it can be added to get this term present on left hand side with a similar dimension. Okay, so this shows that the given equation is dimensionally correct. How could we say that this equation is dimensionally correct? The reason is the dimension of the left hand side and the dimension of the right hand side is the same. So this equation is absolutely dimensionally correct. Now I will solve one problem. This problem 1.14. Here they have asked us to check whether this equation is dimensionally correct or not. What is that? The given equation is this half mv square is equal to mgh. Now I'll check whether this equation is dimensionally correct or not. For that, what I need to do, I need to mention the dimension of each term present here. Okay, see here half is a numerical constant, it do not have any dimension. So they have no dimension. Half, no dimension means raised to power 0. Then the dimension of mass is capital M. There is no power, that means the power is 1. Then velocity, for velocity we have the dimension LT power minus 1. That is raised to power 2 is equal to the dimension of mass is M, power is 1. Then G. What is G? G is nothing but acceleration due to gravity. Now we know the dimension of acceleration, that's nothing but LT power minus 2. We have obtained the expression for that. So that I mentioned here, LT power minus 2. So power is 1. Okay, we have to mention that. Then H. H stands for height. Height is measured in meter. So its dimension is M. Sorry, not M, it's L. It is measured in height is similar to length. So the dimension of height is L. L power 1. Here L power 1. Now let's see what I do. We know anything with a power 0 is equal to 1. So this becomes 1. Then M power 1, L power 3, L power is 1. It is multiplied with this. You get L power 2. I am going to expand this. When I expand this particular part, I obtained the following. L power 2, then T power, this minus 1 is multiplied with 2, power 2. So T power minus 2 is equal to this one here. I am going to expand this part. M power 1, then L power 1. Already we have this. So I am going to write it here. L power 1, then this one is written here. T power minus 2. So what do I get in the next step? M power 1, L power 2, T power minus 2 is equal to M power 1. Here these two are multiplied. So the power becomes 2. L power 2, T power minus 2. If you look at the right hand side and left hand side of this equation, you may find both provide the same dimension. So this shows that the given equation is dimensionally correct. Correct? Box this. This shows that the given equation, EQN stands for equation, is dimensionally correct. I hope I have understood. Now we'll go to the next application of dimensional analysis. Now we will discuss the third application of dimensional analysis. It says that dimensional analysis can establish the relation among various physical quantities, as I told you earlier. Now, suppose you have a physical quantity Q, which depends on Q1, Q2 and Q3. Where Q depends on Q1, Q2 and Q3. Then mathematically it can be written as Q is directly proportional to Q1 into Q2 into Q3. Here, these three quantities are raised to power A, B and C. Then the next step, what is done? I remove this proportionality. In such case, we include equal to sign with a constant. Here K is a proportionality constant which do not have a dimension. It is a dimensionless quantity. Then Q1 power A, Q2 power B, Q3 power C. And after that, if we substitute the dimension of each term on both sides, then the comparing the powers of M, L and T on each side, we can get the value of A, B and C. But I am going to explain you with the help of few examples. Let's go into that. First, I'll solve problem 1.15. Here, we are asked to find the relationship, or we are asked to get the expression for time period T for a simple pendulum, which is said to be directly proportional to or depends on mass of the bob, length of the pendulum and acceleration due to gravity. When T depends on M, L and G, then mathematically we write it as T is directly proportional to M into L into G. Now I raise these three quantities to power A, B and C in this manner. The next step, when you remove proportionality, you get this equation. T is equal to K. Here K is proportionality constant. The value of K is given as 2 pi n power A, L power B, G power C. Now look at this carefully. How do I get the value of A, B, C? So for that, I am going to mention the dimension of these terms. See, the dimension of time is capital T, the time period. Power is 1 is equal to, here K is dimensionless constant. So the power is 0. like this. Then dimension of mass is capital M power A. Dimension of length is capital L power B. Then dimension of G. What is G? G is acceleration due to gravity. So the dimension of acceleration can be used here. It is L T power minus 2 raised to power C. Alright? We know L anything raised to power 0 is 1. So by multiplying this with the remaining term, we are not going to make any change. The next step, see what I do. This. I am going to write the dimension of time period in terms of mass, length and time. So what I get? M. I raise it to power 0. Time period have 0 dimension in mass, 0 dimension in length and 1 dimension in time. This is what it shows. And here 1 M power A. Now expand this. L power B. Then each term is raised to power C. So L power C. Then T power 2 C. This is what I get. Now the next step, what I will do? See, here we have L power B, L power C. I am going to combine these two. So what I will get? When one is multiplied with this value we obtain. M power A, then L power B plus C. When we multiply two terms with different power but of the base of same type, then in such case on multiplication we need to add the power. Remember that. Already I have told you. Then T power minus 2 C. Now the equation obtained is this: M power 0, L power 0, T power 1 equals to M power A, L power B plus C, T power minus 2C. Now if you compare the powers of a single term on each side, you will get A. In the place of A we have 0, A equals to 0. In the place of B plus C we have 0, equals to 0. In the place of minus 2C we have 1. So here C is equal to 1 divided by minus 2, so written here. So C is equal to minus half. Now A value is nothing but 0. That I am going to box. After that, now B plus C is equal to 0. We know the value of C. So I am going to mention here. B plus minus half equal to 0. So what I get? I get this. B minus half equals to 0. And that's nothing but this. B, where the half is taken to this side, it becomes plus half. So the value of B is plus half, the value of C is minus half, and the value of A is 0. This I am going to substitute here. This I am going to substitute here in this equation. So what I get? I get this. T equals to K M power 0, then L power A plus of B, right, its value, L power half, then G power the place of C, right, its value. or half. So this is obtained. Now the next step, what I'll do, I'm going to substitute the value of k. I told you earlier k is nothing but 2 pi. So k is equal to 2 pi. N power 0 is nothing but 1. Anything raised to power 0. Anything raised to 0 is nothing but 1. So that's what we get. Now L power half into g power minus half. This can be written as t equals to 2 pi. See what I do? Look at this carefully. Alright, L power half. So I take this term to denominator. So minus half will become plus half. Now if you look at this part of the equation, you will find both of them have same power. So I simplify this one and write it this manner. T equals to 2 pi L upon G raised to power half. This is what we get. Remember this, anything raised to power half is nothing but root of that value. So x power half is root of x. Then L divided by G to the power half is nothing but root of L by G. So this can be written as is equal to 2 pi root of L upon G. Here it is nothing but root of L upon G. This way we have obtained this equation. This is the final expression that relates time period of a simple problem with the length and acceleration to gravity. Here mass is missing. This shows that the time period of simple problem depends on length and acceleration due to gravity, and it is independent of mass of the block. I hope you have understood. This is how one can easily establish the relation among different physical quantities using the method of dimensional analysis. Now I will solve one more problem for the better understanding of this method of dimensional analysis. According to the next question, the force F acting on an object moving in a circular path is found to depend on mass, velocity and the radius. Here R stands for radius of the path in which the object is moving. So we relate this one as F is directly proportional to m power A, V power B and R power C, something like this. Then this can be written as F equals to K. What I have done? Here I have removed proportionality, and in the place of that I included equal to sign with a constant. Here K is a proportionality constant. It does not have dimension. So remaining things are written as m power A, V power B, and R power C. Now the value of A, B and C can be obtained if we know the dimension of all these terms. First, the dimension of F. Force is the dimension of F is nothing but force. We know force is the product of mass and acceleration. Mass and acceleration. So the dimension of mass is capital M and the dimension of acceleration is L t power minus 2. So the dimension of force is m L T power minus 2. Here, when the power is nothing, that means the power is 1. We know that. So L power 1, L power 1. The next, you know the dimension of M is, mass is capital M. The dimension of velocity is L T power minus 1. We have obtained that earlier. Then the dimension of R. Then R is the radius, which is nothing but the distance between center of the circle to the circumference. So its dimension is L. So I am going to substitute the dimension of each term. What I will get? I will get this. L power 1, L power 1, T power minus 2 equals to, here this dimension is constant. So K power 0. Then L power A. Then the dimension of velocity is Lt power minus 1. This is raised to power B. Then dimension of radius is L raised to power C. Now I am going to simplify this. Then K power 0 is nothing but 1. Okay. Multiplied with remainder 1 power A, and here we have 1 power B. Well, actually I am expanding this. Now the T power minus 1 is multiplied with its power. So we get T power minus B. Then here L power C. So the next step, what I get? To get this. M power 1, L power 1, T power minus 2 is equal to M power A. Now L power B. We have one more here, L power C. Then T power minus B. Now see how I am going to simplify this. Look at that way. I write it like this. M power B. Then L power B plus C. Because I told you earlier. T power minus B. Now you compare the power of M, L and T on both sides. By doing so, what do you get? Here A. The power of M is A. Here the power of M is 1. So here is equal to 1. Here the power of L is B plus C. Here the power of L is 1. So you get this. The next, the power of T is minus B. Here the power of T is minus 2. So then here, okay, this minus and this minus will cancel, and what we obtain is this. B equals to, I box this, got the value of B. I will have the value of B. So I box these two. I must know what is the value of C. For that, I substitute the value of B in this equation. So B is 2 plus C equals to 1. Then the next step, what is done? It is taken this side. So reduce over plus 2 will become minus 2. C is equal to 1 minus 2. That is nothing but C is equal to minus 1. I box this. This is how we obtain the value of A, B and C. Now I am going to substitute these things in this equation. So I write that one here. F equals to K L power A, B power B, R power C. Correct? Now I am going to substitute the value of A, B and C. Here K has got the no value. So is taken as the place of k array to 1 dimension. So this is good enough. Then a is equal to 1 in power 1. Then b is equal to is that 2. Then the place of c minus 1. So what do we get? We get this. F equals to m b square r power minus 1. Now r power minus 1 can be written as, you see, r power minus 1 can be written as 1 upon r. Okay, remember this. So F equals to mb square into 1 upon r. So the final equation obtained is mb square upon r on multiplication. What is the final expression which gives us the relation between F, M, V and R. So this is the expression for the centripetal force acting on an object moving in circular path. So this is how one can use a dimensional analysis method to establish the relation between physical quantities. I hope I have understood. Now, we will discuss some of the limitations of this method. Using a dimensional analysis method, we can check whether the given equation is dimensionally correct or not. But we cannot check whether the equation is absolutely correct or not. That is the biggest limitation of this method. For example, if I have this equation, S equals to ut plus half at square. This is the second equation of motion. The equation of motion. Here, if I use this method to check whether this is dimensionally correct or not, so what I will do? Let's see. Here S stands for displacement. So the dimension is L. Here U stands for initial velocity. Dimension is Lt power minus 1. For time we have t. Then half is a numerical constant. Do not have a dimension, so it will get as such. Then A is acceleration. Its dimension is Lt power minus 2. Then for time we have to raise to power 2 according to the equation. Then see here this and this will cancel. See away this and this will cancel. What you obtain is this. Again for this part. So according to principle of homogeneity, this equation is dimensionally correct because it has got the same dimension on each side of the equation. Now, slightly modify this equation. I write it like this. Half of S is equal to ut plus half, I write it as 1 by 3 at square. Instead of 1 by 2, I write 1 by 3. Now, I apply the same method to check whether it is dimensionally correct or not. Okay, what I get? There, dimension is L. Dimension of U is Lt power minus 1. The dimension of T is capital T. Then it has no dimension, so nothing right. The dimension of A is Lt power minus 2. And the dimension of T is capital T raised to the power of 2. Now, see this cancel each other. This and this will cancel each other. The T power minus 1 divided by the multitude T is 1. This is t power minus 2 multiple t power 2 is 1. So the next step we get L this side and here L and also L. You see, this shows that this equation is dimensionally correct, but it is not the equation of motion. So here this method fails. It cannot say whether the given equation is absolutely correct or not. Okay, this is one limitation of dimension analysis. Now, apart from this, suppose there is an equation which involves more than 3 physical quantities. In such case, we cannot use this method. And also, if there is any trigonometric values present, like sin theta, cos theta in an equation, again we can use dimension analysis for such an equation. Not only that, if we have certain constants like 2 pi or just pi or something else, some dimensionless constants or some numbers like 1, 2, 3, something in an equation. Even in such case, we cannot use this method to analyze it. So these are some of the limitations of dimensional analysis. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your question in the comment section. Thanks for watching.